Hi everyone, my name is Taryn with Quest, and today's webinar presentation is Are You Ready to Harness the Power of 10 for Your Oracle Database with Wayne Martin with IBM. So a few housekeeping notes to go over before we get started. All attendee lines are in mute and will stay in mute throughout this session. If you do have any questions, please feel free to put those into the question drop-down box located on your GoToWebinar panel, and we will answer those at the end of today's session. And this is recorded and it will be on the Quest content library. So at this time, I'm going to hand it over to Wayne, who will get things started.
Good morning, and thank you for attending today. This is Wayne Martin from IBM. I work extensively with Oracle to deliver their technology projects and products in particular on IBM systems. And today we're going to be talking about a white paper that we prepared for the release of our new Power 10 system. First, I want to thank the rest of the team that worked with us on this project. They're listed here on the title page. And let's get ready to harness the power of 10. Quick agenda. I won't read each one out, but we'll talk about the IBM relationship, what we set out to do, what experiences we had, including some notices of how much more capacity we saw and how we configured. We'll also talk a little bit at the end about some of our new Oracle and AIX collections that help you speed up your deployments and really streamline and make those more precise. And a quick note on where to find them. I'll point out that the materials I'm presenting today were based almost completely on this technical white paper, Modernizing Oracle Database on IBM Power. That paper reflects the objectives of this session, which includes both getting Oracle database version current up to 19C, and also getting older Power systems up to the current Power 10 level. The advantages for both of those operations and exercises on your part will become apparent as we move through the presentation, but feel free, if you're interested, to download the paper from the link provided. IBM and Oracle have been working together for a great many years, something many people don't recognize, and we continue to. The products we work with them on span everything from mainframes running Linux over to Power Systems running AIX, the newly introduced IBM Power Systems Virtual Server, which, if you're not familiar with, is the ability to get access to AIX, System I, and Linux Power Systems in a self-service environment that you may find useful for various tasks, and we'll be doing follow-on materials on that. System storage, of course, and even IBM software is coordinated with Oracle products because there's a real need for that interoperability. And we continue to do this because, frankly, IBM has 80,000 joint customers with Oracle, and that really drives an important part of our relationship and the joint investment on both Oracle and IBM to do this. As I said, we have 80,000 clients. This is not just systems. This is 80,000 clients, many with multiple environments. This is a long-term commitment, and Oracle has made their statement that I referenced above, this document ID, which you can view online. There's no restricted access to it. You can see Oracle's commitment to deliver upcoming versions of the Oracle. For now, Oracle and IBM both recommend the use of their long-term release, 19C. And the Power 10 makes very good use of 19C. One of the things that Power does deliver is this compatibility across the realm of machines. So we can actually have Oracle running seamlessly across multiple generations of Power systems, as well as multiple versions and releases of AIX. And yes, we're even looking forward to having support for the upcoming AIX 7.3 release later this year. So we're already working with Oracle on how to plan that. And of course, all those environments can move seamlessly over to the Power Virtual Servers, which use the same operating system, Power VM, as you have available today on your on-premises systems. So it's a very important ability to migrate along and stay current. So why do we need to be current? Oracle has been going through a phase where they've had a lot of versions of their database available and in support for a long time. For this work, we actually focused on 11GR2 because from working with Oracle and looking at our customer base, we know there's still a lot of customers using that very old version. That's been in support for over a decade now, and it's reached the end of its extended support cycle and now has just very limited market-driven support. We want to work with customers to make sure they're able to upgrade off those older versions. It helps Oracle in their management of customers. It helps IBM because we don't have to worry about sustaining customers on older product platforms also. And we're very anxious to work with Oracle and excited to work with Oracle to move them up to database 19C. So many reasons. Long-term support. Once you move to 19C, you don't have to make major changes of releases for a long period of time. Maintenance costs are higher on older releases such as 11GR2. Security, especially now that 11GR2 is passing out of support and into market-driven support, will become more of a concern. And we think overall efficiency, and we'll present some of that. So there are all these important elements of this. A quick disclaimer. We did results. We selected some specific workloads. We selected a specific machine, a specific storage machine. All those elements are things that are unique and specific to our case. We want to present those in a general way, but of course the results that you experience may be different depending on your workload. So we selected two workloads that we had some experience with. One is OLTP, online transaction processing, and the other is a set of business analytics queries that we use in other testing. What we did is we ran each one of those workload sets on a Power 8 system. That's a 2-generation old system, one that many customers are still using, and indeed many of those customers might be using those on 11GR2. So we also selected 11GR2 as the older database version. We started out by running the workload on that machine. We cranked up those machines to have full utilization, and we configured them as best practices. So one of the things we did before we started the project is we made sure we had AIX up to current levels. We made sure we had 11GR2 up to the most current levels. And that's one of the things we really want to encourage in the course of this material is when you're preparing for upgrades, get yourself on current software levels. It'll make your life easier in terms of support from both IBM and Oracle. So as I said, we started out with 11GR2 on an older Power 8 system with the objective to move to a Power 10 and to 19C. So we upgraded 11GR2 up to the 2020 RU. That was the last extended support RU that was created by Oracle. Some people may have market-driven support extensions. We did not make use of that. We stuck with the standard one. And we validated that 11.204 is supported on AIX 7.2, and we used the Oracle Certify tool on My Oracle Support. The fact that 11GR2 is confirmed by Oracle as supported on 7.2 meant that we could then go and upgrade our systems to 7.2 TL5 Service Pack 2, which is the minimum requirement to run on Power 10. So thinking back to the earlier chart, this range of support for Oracle products, even older products, allows us to move to current versions of AIX and allows you to get on our newest hardware. So we installed AIX 7.2 TL5 Service Pack 2, ran 11GR2 on that, validated that we were able to find a common release of AIX that both the Oracle version, 11GR2, 19C, and our target and source machines supported. We're able to do that. We document our supported AIX versions on what we call these system maps. They're available for anybody to view. So the important step for you to make is make sure when you validate any kind of upgrade, look at the Oracle certification matrix, make sure you understand your Oracle supported versions, look at the AIX version requirements, and then integrate those two pieces and make sure that you can identify a compatible level for both product sets. And that's the exercise we went through. So the first workload is what we call the brokerage or OLTP workload. This may resonate with some people, but we took some queries that represent the transactions and database of a stock brokerage firm. We used a 1 terabyte database, 50,000 customers. We did adjust the transaction mix, so this is not repeatable outside of our environment because we selected a certain set of transactions. We wanted to drive much more CPU load so that we could really evaluate how our systems behaved, not the storage subsystem. So we used transactions that had a higher read ratio and pushed the read-write ratio up to 90-10. And again, we did that because we wanted to focus on the behavior of the Power 8, the Power 10, and how the database is performed as a CPU version at the CPU level. We didn't want to do a lot of I/O and stress the storage subsystem. That's not the immediate objective of this paper. So the 11GR2 database, we put it on an E870, one of our enterprise systems from 2 generations ago. We used 48 CPU cores, 48 physical cores. We looked at how that machine was configured and we placed those cores in what we call 2 nodes. And then we exercised the workload and achieved a measured transactions per second rate. And we pushed that rate up to 100%. So our initial baseline was 11GR2, as many transactions per second that we could achieve running the Power 8 48 core node at 100%. So for illustrations, these are the 2 machines we used. The Power 8 is the 870, 48 cores. And as you can see here, we did a rough sizing and evaluated our Power 10 that we would only need 24 cores. And we crafted this Power 10 configuration. So as I said, 11GR2 was driven to full utilization at 48 cores. We implemented a Power 10 LPAR. We used our Power RPerf report to give us the estimate of 24 cores. Created that LPAR, and then we stopped it on the Power 8, realigned our SAN so that we could connect the database to the new one and restarted on the Power 10. We then ramped up the workload to a very similar transactions per second on 11GR2 and made a record of how we achieved that at 100% utilization. We then upgrade to 19C, doing an upgrade in place. The auto upgrade utility was used, and then we ramped the workload up again on 19C. Some people may have a more complicated process. We didn't have many one-off patches to apply in this scenario. You'll notice the one that was applied for 11G here. You see the similar workload. What else would we want to call out? On the Power 8, the SMT level was default at SMT4. An advantage of the Power 10 is we can now push it to use what's called SMT8. So that's symmetric multi-process. That's shared multi-threading, SMT. And that allows you to make full use of the processor core by running multiple threads in each core. So you create more virtual processors on the system. Okay. So again, graphically, we start out on our Power 8 with a logical partition. We do the SAN switch to move the database over to the new logical partition. That's on the IBM Power 10. We fire up the database 11GR2, run our workload, auto upgrade to 19C, and then as an additional experiment, once we are in 19C, we went from a non-container database, which was not available with 11GR2. We moved on to the container database. We wanted to look at that because moving forward, Oracle has announced that all future databases will be placed in a container. 19C is the last version that allows non-container database deployments. We wanted to understand what kind of behavior we saw when we placed the database into a container database, and then we reran again. I'll point out we used 1911 for this. That was the current version when we started this project. A note, I mentioned before that we did good placement in our tests of where the processes were allocated to this workload. We used the LSRAD tool. SRADs are a description. This is a command that allows you to understand what cores are being used for a particular logical partition. 48 cores on the Power 8 required the capacity that spanned 2 nodes of the system. And that's because each chip on a Power 8 has fewer cores, and also the number of cores that were required. When we went to the Power 10, we were able to contain all 24 cores on a single node. And that allows us to better consolidate. It gives us a little bit of a performance advantage to have that placement all local to a node. And obviously, it also means that you don't need as much capacity to get the same number of transactions per second. Okay. Couple notes. We ramped them both up to 100%. We achieved similar transactions per second. We did notice that the execution plans, when we did the upgrade from the Power 8 to the Power 10 on 11GR2, they did not change. So we retained the same execution plans. That was important because that kind of change can often throw surprises at you. So when you do an upgrade, we didn't see changes, but it's always good to make sure your plans are remaining consistent. That's an area where your application might see differences if somebody makes a change in the optimizer. The improvement we did see was due to the move to the Power 10 system, but your optimizer did produce the same query plans as it did in the first place, which is a good outcome. When we upgraded from 11GR2 to 19C, we did see some plans changing, but they didn't substantially change the throughput. So they were effective, they were not disruptive, and we were able to continue running at the same levels. So we did do the upgrade and the compatibility and no other configuration changes. And again, the execution workload did not change. So what did we see? So on 11GR2, our baseline of 1, 48 cores. When we moved to the 24 core, we saw 2.5 times more throughput because we did see an improvement in transactions and we were on half the number of cores. So we saw a better than 2x performance benefit. Indeed, when we went to 19C, we saw very similar results, a slight drop off, if you can see from the graphic. And then moving to the container database, again, we saw a little overhead, but nothing substantial. So I think we saw pretty good consistency moving from the Power 8 to the Power 10. We saw a very strong benefit in throughput. Moving to 19C, we did not see any disruptions that were significant. And moving to a container database, we saw a slight bit of overhead, but still nothing that would be an overwhelming concern for us. Moving on to our business analytics. So we use what's called BI Day. It's an internally developed analytic workload that models analyses that a business can use in a BI workload. The name says it's all. This is a 1 terabyte database with a fact table that we'll be focusing on. That fact table, as described, is filled with 9 billion rows. we crafted 26 queries that run from very simple queries to very complex. We run those queries in the same order every time and with each one of the users. So when we talk about more users, we're actually running the same set of queries in the same order on the machine simultaneously. So these are all accessing the database. So the users represent multi-processing and multiple uses of the workload. The machine we used here was slightly different. It was a different model Power 8. It was an E880. Again, we started out with an SMT value of 4, and on the Power 10, we used the default 8 for SMT. We used the same set of one-off patches for 11GR2, and a note I'll make is on the Power 8, the frequency was set at a fixed point. Power 10 uses much more intelligent energy management tools and allows the frequency to vary. So we were running in a mode that let the machine use its full maximum speed. Depending on your workload, the machine will cycle down if the workload is not as heavy. That is under the control of the users, but we use what's called workload optimized frequency. That's a strong feature of Power 10 that lets you balance energy use with performance and throughput. This is a very wordy page, but I'll let you read it in detail if you care to, but we set up the BEI day to run the number of users that best leveraged the available capacity of the machines. We also matched the parallel degree policies and limits to match what the virtual processor on the machine was. So we set these up to make full use of the number of processor threads that were running on each machine. Indeed, that would be similar numbers on the two machines, although the Power 10 was set up with 27 rather than 24, so it had a few more cores available to it and a few more threads. If you think about it, if you have 48 cores on SMT4, you'll have a similar number of threads with 24 cores on SMT8. But so we set up these parameters. The details are in the white paper, but I encourage you to look at that. So we ran BI Day two ways. The first, starting with 11GR2, is in what they call their usual row format. In this scenario, it's set up as the database is. The fact table is read across the rows using the row format data. This typically is a heavy operation requiring a fair amount of I/O in order to read across all the rows of that table. Remember, it's 9 million rows. So we set that up, as you see there, but we also decided to use the newer in-memory feature, which is available in 19C and actually in a couple earlier versions, but it's been strengthened in 19C. In-memory allows us to put the critical fact table into an in-memory location and read it in columns rather than in rows. It also allows us to use optimized arithmetic and store the data in a native format. So that's reading the data not in the Oracle data format, but in one that's native to the machine, which allows the machine to work much faster. This did require a small increase in the SGA target of 200 gig. And we set that substantially based on the in-memory size, which is how you activate the in-memory feature. And again, this last one is a fairly new feature, which is the in-memory optimized arithmetic, which allows you to use native representation of the data in the table that's stored in memory. We did a similar thing in moving to this. We started out with 11GR2. We switched the database over to the Power 10. We restarted 11GR2 on the Power 10. We did the upgrade using the auto upgrade features and moved on to database 1911. Again, we used the LSRAD tool, the SRAD tool, to make sure that we had good placement. I would recommend anyone do this. There are various optimization tools, but awareness of how to get the most out of your system often comes from using some features like this as well. We estimated this as potentially taking a little more capacity, the 27 cores, so we weren't expecting to get a 2x, although we were pleasantly surprised. So again, as I mentioned, you have a binary float referring to floating point numbers. I'll also note that we were able to compress the table. So the sales fact table would have originally taken 726 gig of memory, but we did turn on compression, and this reduced it to less than 200. This is what drove the substantial part of our increase to the SGA target. So when you move to in-memory, you do have to allocate extra space, but I think you get a substantial benefit from that. So this is a log scale. The other table I showed like this was a linear scale. This is a log scale because the 146 times improvement in throughput per core was so substantial that we couldn't fit it into a reasonable size table. So moving to the power 10, we did again get a 2.5 times speed up per core. So we actually could have lived with fewer cores because we got a similar speed up. Interestingly, even with the traditional row format, we saw benefits from database 19C. So remember, moving from 11GR2 row format to 19C, we again saw improved benefits on our processor, on the Power 10 processor. So another benefit of moving to 19C. And then finally, the very substantial benefit of moving to this 19C was the ability to use the in-memory. So remember, when we get this increased capacity, you are really getting back the CPU capacity that would have been spent doing the row-oriented scans. You're getting all that back and saving it for other workloads. So even though in-memory is a separately priced option, I think if you're doing any amount of analytics, you may find it to be a very effective tool to improve the utilization of your systems and the utilizations of your overall investment in Oracle software. So I encourage you to take a look at this, and we've done some other materials on this. And I'd love to hear about other people's success or experiences with the in-memory feature. So in summary, we wanted to encourage customers to look closely about their plans. We focused on 11GR2 moving to 19C. That seemed to be, at the time of this writing, probably the area that Oracle and IBM were most interested in moving customers to. We also see, looking forward, we're very interested to working on a 12C to 19C project in the not too distant future. And we're already starting to work on that. And I'm glad to take some input on what people might like to see or what they might like to see done differently when we do a 12C to 19C experiment. Important points that I want to take out of this. We updated the Oracle release we were starting from to the current patch set. And in the case of 11GR2, some customers might still be running on 11.202, 11.203. We would very much want you to be on 11.204 and on the current RU. So try to get your existing Oracle installation current on the existing system before you start to make any other upgrades. Get your database version current. That gives you consistency with what Oracle is managing as support. It gives you consistency what other testers are seeing. Having done that, do your AIX update. Get it to a level that both the Oracle version supports and the new hardware supports. That way you can evaluate how that AIX version runs on your existing hardware and you'll be well prepared to understand and have expectations on how it would run on the new hardware. Make sure you're at the most current version. I've mentioned in the charts a couple times we used AIX 7.2 TL5 Service Pack 2, but since we did this, Service Pack 3 is available, and that provides much better default characteristics for the Power 10 system. So we recommend going to Service Pack 3 right now. If at all possible, use the Oracle tools that provide compatibility. Auto upgrade. We use those tools. Oracle makes them available to try to ease the challenges of going to a new version. Using auto upgrade gives you, or should give you, better consistency when moving from one version to the other, and it minimizes surprises when you do the upgrade. In addition, we make sure your firmware is up to date. Make sure if you're using virtualization that the AIX Virtual I/O Server, VIOS, is up to its current levels. That's both on the source machine, your original machine, your older machine, as well as your new ones. Get your software current. Your life will be easier. And make those changes on your base machine first so that you've already seen what the behavior is. And then the final suggestion is really look at this in-memory feature. It uses the native capabilities of our systems. It uses the memory, the large amounts of memory available on the AIX systems. It uses it very well. One of the reasons we run the in-memory database is to evaluate if the system's performance can keep pace with the heavier memory use. That was one of the reasons for running this. We found that this to be a very positive benefit. But again, be methodical in your approach to doing upgrades. If I could share one experience, it's when I see too many jumps being done at one time that customers are often getting into problems. And again, this material is based on our white paper, Modernizing Oracle Database and IBM Power. I attached a link where you can find it on the IBM website. So moving on to a slightly different topic, we've also developed some automated power system provisioning options. We're using the Ansible tool. This tool allows you to create collections of scripts or software that lets you basically automate repeatedly and accurately and precisely the way things are laid out. So this allows you to set up your AIX and your Oracle on it. If you're like many customers, you're not just running Oracle database on one LPAR, you're probably running on many LPARs. This sort of control allows you to set up a model and repeatedly deploy it and do those new deployments faster. Excuse me. 4 steps, the Yum Python install. Looking forward to upcoming versions of AIX like 7.3. Yum will actually be part of the operating system, so one of the benefits of moving on to AIX 7.3. So having Yum allows us to pull in all the components for the Ansible in an automated way. Step 2 is the pre-configure steps. This is where we set up the necessary file systems, do some tunables to be consistent with your needs, and set this up so that it's ready to take on the Oracle workload. We then go on and support the Oracle installation. We do a lot of things automatically, update the profiles, you provide the input, and we apply them in the right places in a way that'll give you consistency. And then we go ahead and create the database using whatever appropriate tools are available. Quick look at the block diagram. Pretty much the same thing. And I'll point out that since we did this, I noticed that we have the single instance database available on GitHub and Galaxy. We've now added to this collection a rack implementation that runs on ASM. I don't have the materials ready on that one today, but we actually have an Ansible automated implementation of rack that runs on AIX, and that was posted this week on GitHub and on Galaxy. And I would really welcome input from this community on whether these tools are working for you, whether they're working valuable. The people to go back to are in the GitHub and Galaxy links, and I'd really value input from this community on these two topics. Quick update. Many people ask us what our support coverage is. These are the groups that you go to engage your local specialist in a pre-sales. The tools in the lower left of this chart are the ones that can help you prepare what the capacities you would need on a new machine are. These let you get prepared and do the analysis that we did based on the RPERF numbers, perhaps more accuracy and more specific to your workloads. Those tools can actually take your AWR reports and evaluate if what the performance needs are and how they'll behave on the new machines. So that is part of the prep process, and IBM is there to support those activities. And then these are the steps that go on when you go through the process. And that's the end of my prepared comments, and I'm very happy to turn it over to any questions or answers that may come up at this point, and appreciate your time.
Okay, thank you very much. And just a quick reminder to all the attendees, if you do have questions, please put those into the question drop-down box. So we'll go ahead with the first question that we have. Can you explain the environment for Oracle and containers?
The Oracle containers is a different technology. On AIX and Power, Oracle is supported in what are called logical partitions. Each logical partition embodies the AIX instance. It's not a container as I would define it in a Linux environment. AIX is different. In addition to an LPAR, Oracle does support something called a workload partition, a WPAR. WPARs provide essentially a containerized environment for single instance Oracle databases so that you can containerize and allocate resources to multiple deployments of Oracle, each with its own containerized version of AIX, all on one LPAR in one AIX level. But from an Oracle in a container, that's not part of what you can do today on a Power system.
Okay, thank you. And the next question that we had is, do other Oracle applications and middleware run on Power 10?
Yes, they do. Oracle, as a general policy, supports their products on any platform for which IBM supports the AIX operating system, or if it's like a JDE application, the I version. So for the most part, Oracle is able to provide compatibility across all the physical platforms that we have. That's an important element of that chart I showed earlier, showing the ability to move up and down the line of Power 8, 9, and 10 easily based on the operating systems that are deployed underneath it. Thank you for that question.
Okay, and the next question is, which version of XLS compiler is used for newest Oracle versions compilation?
So 19, and I think the reference here is what version of the XLC compiler. That's IBM's compiler that is specifically optimized to make the best use of the Power architecture. The XLC compiler 13.1 is used for database 19C. We are working with Oracle to move to newer versions of XLC on newer versions of their code. So that's an area of active and full engagement. There is an Oracle note which describes the supported compilers for older versions, which I have to admit I can't remember from memory, but there is an Oracle note that describes the supported compilers, and typically the oldest one is the one that the compiler was built with as a native platform. But XLC 13 is where 19C was built. And that was the current version of the compiler at the time that 19C went into construction. Thank you for that question.
Okay, thank you. And the next question that we have is, if we use Tools 2.0 to expand and contract resources, does Oracle licensing deal with that?
Wow, say that one again. Tools 2.0. Which people tools, or I'm not sure.
Wayne, it's Pools 2.0.
Pools.
Enterprise PEP.
Enterprise pools.
Oh, sorry, I misread that. Sorry, I was reading too fast.
That makes sense now. Enterprise pools is a feature for making physical capacity available on an IBM Power system. Oracle license compliance is very much the focus of what the customer has to do. But if you're licensing on a per core basis, which many customers do, your need is to make sure you stay aligned with the number of cores that you make available to Oracle based on what your enterprise pools is providing. So Oracle's, if you're licensing 10 cores for your environment, 10 physical cores, 10 licenses requires, you need to make sure as you use enterprise pools, you don't exceed your Oracle license available inventory. How you work to balance that is part of the customer to Oracle relationship, and that has to be maintained with the customer. But again, logical partitions are hard partitions in Oracle's licensing parlance. So if you run 2 partitions with 5 cores each, that would be 10 cores. If you have a 10-core license, you're good. If you use enterprise pools and shift that around, as long as your total capacity of your logical partitions stays under the limit, you should be okay. But again, check with your Oracle representative if you have any questions. And make sure as you use enterprise pools that you stay in compliance with the number of cores available in your hard partitions running Oracle. Thank you for that.
Okay, and we have a comment that also came in after. So I believe the IBM recommendation is to manage Oracle licensing via LPAR profile and or shared processor pool. This is a separate constraint for what enterprise pools do from a core activation perspective.
I prefer to look at it in a more simple way. I look at it from the Oracle perspective. Oracle requires the customer to have valid licenses for the number of cores available in the LPARs Oracle is running in. And to go back, Oracle defines something called a hard partition. And the capacity of a hard partition, an LPAR qualifies as a hard partition. What you do is you calculate how many cores are available in the LPARs of your system. If you're using enterprise pools, shared processor pools, you need to make sure that the maximum number of cores allocated through those tools is going to stay within the limits set by Oracle. So I tend to look at it as a fairly simple question. Are you maintaining compliance with the number of cores available? If you're using a ULA type license, you need to think about it in a different context of what your overall use is. But in terms of core management, it's really what counts is how many cores are available to Oracle and that you keep that number available under. A lot of questions on licensing, not surprising. That, Doug, we may want to take that up as a topic for a future call and find the right partners to do that.
Okay, thank you for that response. And then the next question that we have is, what are the plans for Oracle database in the upcoming AIX 7.3 release, which was announced earlier this year?
We're working with Oracle. As you know, 7.3 is announced, but not generally available. I anticipate with a strong focus on making sure 19C can run on 7.3 And we'll also evaluate, as I said, this binary compatibility statement for earlier versions of the database and what can be supported on 7.3. So I anticipate that 19C will be available with the existing features that are currently supported on AX 7.2. I anticipate that 19C certainly will be available on 7.3, very close to when the GA of 7.3 occurs. As always, that's an objective, and if we have surprises, the timing may change, but that's certainly my objective, is to get those done as soon as possible.
Okay, and in response to that, so what about Oracle certification for WPAR Oracle 19C is not certified anymore?
We just published certification of 19C single instance on a workload partition, a WPAR, within the last 30 days. So 19C single instance is now certified to run in a WPAR. That was a fairly recent development.
Okay.
And that's what, when you said WPI, I think that's what you meant, a WPAR, right? Is that the way that question reads?
Yes, yeah.
Okay. So that was recent, so you may want to check back. And if you see any errors, let us know, but I'll double check. But that should be pretty recently listed.
Okay. And the next question is, what features of AIX 7.3 will Oracle make use of?
Our top priority is to make sure that the ability to use 240 physical cores, the power 10 increases the maximum number of physical cores on a system. And one of our top goals is to make sure Oracle runs well with that increased number of processors. And when I say that, that means even the ability to run all those processors in a single LPAR. We've already started that work. We had identified some concerns when we were running on very large single LPARs, and we'll continue to run and work with Oracle to identify issues in that area. 7.3 is at this point very focused on Power 10 support and making full use of those capabilities and not introducing a lot of new features, unlike previous versions of AX 7.2. I anticipate 7.3 could very well roll out additional features over the course of 2022 and beyond, and we'll be ready to work with Oracle to certify those features as they come up and become available. Thank you.
Okay. And I believe this is the last question that we have. So if I have a Power 9 today, what improvement should I expect upgrading to Power 10?
One of the things I noted a little bit subtly in this presentation is that we use something called the rperf tables to kind of estimate where we would be going from Power 8 to Power 9. What we discovered in those relative capacity increases is that Power 8 to Power 10 certainly scaled in a way that's very similar to what we document in our rperf tables. That was one of the objectives I wanted to set out to do. I didn't explicitly mention it in this presentation, but we're seeing very similar results to the rperf tables. That's important because it gives you a very strong and published baseline to start your planning. Power 8 to Power 10 was consistent with rperf, and you would see the same behavior going Power 9 to Power 10, consistent with our rperf tables. So if you're not familiar with that, I would suggest, let me see if I can go back. Use the link I provided early in the presentation. This is awkward. I think in the beginning, I highlighted the location of that. So the IBM Power, copyright, rperf report is available there. A very interesting, and I see not hyperlinked in this presentation. We also reference it in the white paper that you can download, and there's a little more detail there. But as a first order, you can certainly use how we report these rperf numbers to do Power 8 to Power 10. You could probably even use it to go Power 7 to Power 10, those same rperf tables. And based in particular on OLTP and this analytics, I think you should get results similar to that. Thank you.
Okay, thank you so much. And that is all the questions that we had. So thanks again for coming and presenting with us today. And just a quick reminder that this was recorded and it will be on the Quest content library. So thanks again, Wayne.
You're very welcome, and I thank all the attendees for their time and their excellent questions.
Okay, thanks everyone. Have a great day.
Take care.